Did you know there's a planet in our solar system where a single day lasts longer than an entire year? No, it's not science fiction, it's Venus. This seemingly ordinary planet hides one of the strangest secrets in orbital mechanics, and today we're diving deep into how and why a day on Venus is longer than its year. And what that actually means. Let's start from the basics. Venus is the second planet from the Sun, located just between Mercury and Earth. It's similar to Earth in size and mass, which is why it's often called Earth's sister planet. But beyond those superficial similarities lies a world that couldn't be more different. Its thick, toxic atmosphere is made almost entirely of carbon dioxide, and it's covered in clouds of sulfuric acid. Temperatures on the surface reach over 470 degrees Celsius, hot enough to melt lead. And that's just the beginning of the weirdness. Let's define two key concepts. Orbital period, the time it takes for a planet to complete one full orbit around the Sun. Rotational period, the time it takes for a planet to complete one full spin on its axis, in other words, one full day. Now here's the kicker. Venus takes about 225 Earth days to orbit the Sun, that's its year. But it takes about 243 Earth days to rotate once on its axis, that's its day. So yes, one day on Venus is longer than its year. And it gets even weirder, Venus spins backwards. Most planets in the solar system spin in the same direction as they orbit the Sun, that's called prograde rotation. But Venus rotates in the opposite direction, retrograde rotation. This means if you were standing on Venus, which, by the way, you couldn't, you'd die instantly, the Sun would rise in the west and set in the east. So not only is a day on Venus longer than its year, it's also upside down and backwards compared to Earth's norms. Scientists believe this retrograde spin may have been caused by a massive impact early in Venus's history, or possibly complex interactions with the Sun's gravity and Venus's dense atmosphere over billions of years. But wait, there's another twist. The 243-day figure we mentioned is called a sidereal day, the time it takes for Venus to spin once relative to distant stars. But what about a solar day, the time between one sunrise and the next? On Venus, because of the retrograde rotation and the way it orbits the Sun, a solar day lasts about 117 Earth days. That's shorter than the sidereal day. Wild, right? So depending on how you define a day, you get two very different answers on Venus. This slow spin has baffled scientists for decades. One major theory is tidal locking, the gravitational interaction between Venus and the Sun that gradually slows down its rotation. But unlike our Moon, which is tidally locked to Earth and always shows us the same face, Venus hasn't stopped spinning completely. It's just incredibly slow. Another theory suggests that Venus's dense atmosphere plays a role. Some models show that atmospheric tides, caused by solar heating, could create torque that slows down or even reverses a planet's rotation over time. Basically, Venus's atmosphere may be pushing back against its rotation. Let's imagine, just for a moment, that you're standing on Venus, in a high-tech, heat-resistant, acid-proof suit. Here's what your day might look like. The Sun would creep into view from the west. Over the course of 117 Earth days, it would slowly crawl across the yellow, cloud-covered sky. The surface would remain dim, filtered by thick clouds and hazy atmosphere. Temperatures would never change, day or night, because Venus's atmosphere is so insulating, it traps heat like a pressure cooker. After 4 Earth months, the Sun would finally set. In the east. A full day-night cycle on Venus is a slow-motion, apocalyptic version of Earth's day. Meanwhile, as all this is happening, Venus completes a full orbit around the Sun in just 225 Earth days. So in one Venusian year, the planet has only rotated a little more than once. This means a year on Venus is technically shorter than a day, if you define a day as one full rotation. But remember, due to the weird timing and retrograde spin, you'd only experience 2 sunrises per Venus year. Wild, isn't it? Let's do a fun thought experiment. What if Earth rotated like Venus? A single day would last 243 Earth days. That means 121 days of continuous daylight. And 121 days of night. The temperature extremes would be off the charts. Plants would struggle with the long nights. Life as we know it might not exist, or would have evolved in totally different ways. It gives you perspective on how perfectly balanced Earth's rotation is for life. Scientists have tried to study Venus's strange rotation up close. NASA's Magellan spacecraft mapped Venus's surface in the 1990s using radar, since visible light can't penetrate the thick clouds. Magellan confirmed the slow retrograde rotation, but also found something weird: Venus's rotation is still changing. In fact, It slows down and speeds up by a few minutes over time. That's possibly due to interactions between the atmosphere and the planet's surface. Future missions like Veritas and Envision hope to unlock more secrets about why Venus is so different, and whether it once had oceans, or even life. Venus isn't just a curiosity, it's a warning. Some scientists call it a runaway greenhouse effect. Billions of years ago, Venus may have had water and a more temperate climate. But something changed. Now it's a world of scorched rocks, crushing pressure, and acid rain. And its bizarre rotation is just one piece of a larger puzzle: how planets evolve, and what might happen if we ignore the balance of our own world. Outro. So, the next time you look up at the sky and see Venus shining brightly, remember, you're looking at a planet where a day is longer than a year. Where the sun rises in the west. And where time, heat, and gravity have rewritten the rules of what we think is normal. But now I want to hear from you. What do you think would happen if Earth had a 243-day-long day like Venus? Leave your theories in the comments, and don't forget to subscribe for more mind-blowing space content.